In algebra, you will often come across groups of numbers, variables, and even exponents of numbers and variables. These groups are what we call terms. We've seen these types of groups introduced in the previous lesson when we talked about basic algebraic expressions. For example, a simple term would look like 2x squared, or x cubed, or even 4/3 x squared. We talked about the two major parts of a term, the variable part and the coefficient part. We now look to the part that we left out, the exponent part. Even though we covered a basic look of exponents when we talked about exponents and radicals, we need to have a separate chapter dedicated to exponents because of the complexity of how they perform with other numbers. There are several rules and properties that must be mastered if we are to continue to the study of algebra. We begin with a look at the product rule of exponents. When we first started our study of exponents, they naturally seemed simple enough at first. Unfortunately, they don't stay that way. In many other sciences, situations arise that bring more and more complex mathematics that take more and more time to compute. We therefore have tricks that help us to move through these complexities. This is what the prerequisites of algebra are. We are studying these tricks or these rules we have formulated that help us to solve and simplify more and more complex math. The first rule, the product rule of exponents, is a situation where we have two terms containing the same base being multiplied together. For example, let's say we have two terms, 2 cubed times 2 squared. Individually, we know that 2 cubed means 2 times 2 times 2, and 2 squared means 2 times 2. In other words, we have a set of 3 2's and we have a set of 2 2's. But if we look at it all together, we can see that we actually have a combined set of 5 2's. Because we have two like bases with exponents being multiplied together, we know that we have 5 2's because we can write our terms like this. 2 cubed in parentheses times 2 squared in parentheses, which becomes 2 times 2 times 2 times 2 times 2, which then equals 8 times 4, which finally equals 32. We clearly see that 2 cubed times 2 squared equals 32. We also know that 2 to the 5th power equals 32. What did we really do? We added the exponents together, or rather, we added the amount of times our base is multiplied by itself. In essence, what we did was 2 cubed times 2 squared equals 2 to the 3 plus 2 power equals 2 to the 5th power. We added the exponents. We kept the same base and added the exponents together. This is what the product rule for exponents is. If we had 3 cubed times 2 squared, this wouldn't work because 3 3's and 2 2's cannot be combined together until the computations are complete. For example, you would solve the exponents as 27 times 8 equals 216. The bases must be the same to combine the exponents. Since we had the same base for the previous example, 2 cubed times 2 squared, we were able to combine the two bases. Why? Because exponents are a form of repeated multiplication. As long as there are no addition and subtraction separating the groups of exponents being multiplied, we can combine them like this. Let's see an example of what I just said. 3x squared plus 4x cubed times 2x cubed. In this expression, we have three terms, but only two of these terms can be combined. The product rule for exponents only allows us to combine terms that are being multiplied together. Looking at our expression, we have the freedom to use the product rule for the terms being multiplied. So we obtain 3x squared plus 4 times 2 times x to the 3 plus 3 power. This becomes 3x squared plus 8x to the 6th power. Here's another example to show that we cannot combine exponents separated by addition or subtraction parts. 2x squared times x cubed minus 4x squared plus 5x to the 5th power times 3x to the 4th. This becomes 2x to the 5th minus 4x squared plus 15x to the 9th. It's important to remember that we cannot use the product rule for combining any and all exponents that we see. Just remember, we call it the product rule because it's used only for terms connected by multiplication. Now let's use a variable instead of numbers. If we had x to the 4th times x squared, what we have is a set of 4 x's times a set of 2 x's. What we see is that we actually have 6 x's. We can set this up as x to the 4th times x squared, or x times x times x times x times x times x, which still becomes x times x times x times x times x times x. Nothing changed. 4 x's and 2 x's are 6 x's. What we did was add together the number of times x is multiplied to itself. We can write out our exponential term like this. X to the 4th times x squared equals x to the 4 plus 2 equals x to the 6th power. Why can we say that x to the 4th times x squared equals x to the 6th? Because we added the number of times x was being multiplied to itself. Again, we can see why the base must be the same. If we had x squared times y cubed, just like when we had the 3 cubed times 2 squared, we wouldn't be able to add the exponents together because x and y are not the same, assuming x does not equal y. Now that we have introduced the product rule of exponents as a concept, here is a formal definition. If m and n are in the set of natural numbers, then a to the m times a to the n equals a to the m plus n for all real numbers a. Notice how m and n must be in the set of natural numbers. This means that we cannot use 0 nor a negative number in the product rule. That doesn't mean that 0 and negative numbers are undefined in exponents. We have separate rules for those cases that we'll explore in other lessons. But for the product rule to work correctly here, we use only positive non-zero integers. That is, the set of all natural numbers for m and n. For a, the product rule is valid for all real numbers. Throughout your study of algebra, you will see exponents thrown on everything, even irrational numbers such as pi and e. Before closing out this lesson, we'll do a few examples. And I left the definition in the top right corner of the screen so we don't get lost. As I'm working these examples, pause the video and do them yourself if you want. Try them and see if you can do them. These examples won't be overtly difficult. They'll be quite simple, just enough to get the point across. For 1, we have 4 squared times 4 cubed. We could solve this right now and just say 16 times 64. But Let's keep the exponents. We don't want to evaluate the exponents. Let's simplify the exponents. What that means, I want to see a combined exponent at the end of each question. So for this example, 4 squared times 4 cubed, we have 4 to the 2 plus 3 power, which equals 4 to the 5th power. Number 2, we have x to the 4th times x to the 5th. Now with something like this, we can't evaluate the exponents because we don't know the numerical base of what the exponents are affecting. So for something like this, when that's encountered, you would just leave the exponents in its most simplified state. So this gives us x to the 4th plus 5 power equals x to the 9th. Here's a fun one. X cubed times x to the 4th. Who said there only had to be 2 bases? Do you know what exponent is right here? Just like with coefficients, if there's no coefficient in front of a variable, always assume a coefficient of 1. Same with exponents. If you don't see an exponent to the top right corner of a variable, always assume there to be a 1. This gives us x to the 3 plus 1 plus 4, which gives us x to the 8th power. Let's combine both variables and exponents now. Number 4. In parentheses, we have negative 5xy to the 4th times 3x cubed y squared. We have negative 5 times 3 times x to the 1 plus 3 times y to the 4 plus 2. See how I put it all together like that? This gives us negative 15 x to the 4th y to the 6th. Number 5. Here's a fun one. X divided by 4 all raised to the 3rd power times x squared. Apply your exponent to everything inside the parentheses. We have x cubed over 4 cubed times x squared. Remember, when you have a number or a variable outside of a fraction, being multiplied to the fraction, you always multiply it into the numerator, not the denominator. So this gives us x to the 3 plus 2 over 4 cubed, which equals x to the 5th divided by 4 cubed. That was the lesson for the product rule of exponents. I hope I made myself clear and understandable. If not, let me know what I can do better. If you enjoyed it, give a like to the video. Leave comments, ask questions. I'll always try to answer. If not, I will see you on the next video. So I hope you have a good day. See you later.